Hello there and welcome to the GCSE revision video. Here we're looking at iterative formulae. So let's get started straight away. So what is an iterative formula? Well, it's a formula that helps generate a list of numbers or a sequence of numbers by continually using the previous number in the sequence to generate the next number in the sequence. So what we have here is a sequence that starts on the first row here. This is an example of an iterative sequence, and so is the one below. But in the first example, we've got the sequence and it starts with the number 4. Now to get the next number in the sequence, we use this formula at the start. And it says, use the previous number in your sequence, then add on 3, then square root it, and then times it by 2. So this formula here is a formula that helps you generate the next number in the sequence using the previous number in the sequence. So this subscript here, the subscript is just denoting which term in the sequence I'm at. And in the first one, it'll be x1. And to get x2, the second number in the x sequence, I use this formula. So the way I can use my calculator to do this is by typing in 4, and that will be now the first number in the sequence. To get the next number in the sequence, I need to take that number 4, then add on 3, then square root it, and then times it by 2. But given that 4 is currently the input into my calculator, I can use the answer button to recall that number 4, the previous term in the sequence. So it's going to be on the calculator 2 times the square root of answer plus 3. And that generates for us the next number in the sequence, 5.29. Now to get the next number in the sequence, we're going to now use 5.29 as the x number in this formula. So it's going to be 5.29, add 3, square root it, and then times it by 2. So what we're effectively doing there is using the current answer on my calculator, then adding on 3, then square rooting, then multiplying by 2. So I don't actually need to change any calculation on the calculator. All I now need to do on my calculator is just press the equals button. So press equals, and we get 5.76. And that's now the next number in the sequence. We'll do this a few times and we'll carry on the sequence going. So you didn't need to change anything on your calculator there. You didn't need to retype that into your calculator screen. You just needed to press the equals button again. We'll press the equals button again for the next number in the sequence because 5.76 will be the new input into the sequence generator to calculate the next number in the sequence. So press equals again and we get 5.92. Whoops, 5.92. And then we can press equals again finally to get the next number in the sequence. You can just keep this going on and on and on if you wish to. You just keep on pressing equals and it will just keep on generating the next number in the sequence using the previous number in your sequence. Let's have a look at the question below then. So this time we have to start with the number 3. So that will mean start with 3 and then press equals on your calculator, because now that's the answer value in your calculator. You always have to type in the first number by hand. Then what we're going to do is input 3 into this formula where it says xn minus 1. Don't worry too much about the subscript notation as long as the one on the left-hand side of the formula is one more than on the subscript notation than the formula one, then that's fine. But into our calculator goes this formula. It goes 3 over the square root of 7 minus, and this symbol here is just referring to the previous number in your sequence. And the previous number in this sequence was 3, so it's 7 minus 3. That will give you 4. The square root of 4 is 2 exactly, so it's 3 over 2, or 1.5. Then all we need to do to get the next number in the sequence is press the equals button again, because 3.3 over 2 is the answer value in my calculator at the moment, and 3 over 2 is the value that I'd use to generate the next number in the sequence. So just press equals again, get 1.28. Press equals again and you get 1.25. Press equals again and you get 1.25 still. So actually generally what you'll find is with these types of sequences, especially the ones that we're going to generate, is that they will be tending towards a certain value. Okay, so I've got a couple of more basic past paper questions for us to have a go at now. So pause the video and give this question a go. Okay, so this is just making sure you know how to use an iterative formula. So the number of bees in a beehive starts with year n at Pn. The number of bees in a beehive at the start of the following year is given by this formula here. At the start of 2015, so P 2015, we had 9,500 bees in the beehive. And the question is, how many bees will there be in the beehive in 2018? Right, okay, so we need to go through the sequence generator and go all the way up to 2018. So the first thing we'll do then is we'll type 9,500 onto the calculator, and then we'll type in this formula up here. We won't use Pn, we'll use answer button at that point. So type that into your calculator, and we'll get 1.5 times in brackets answer minus 250, and we get 9,712.5. That's the amount of bees in the next year on from where we currently are. We're currently at 2015 with that 9,500, so 2016 will be one input into the formula. Then we'll press equals button again because we want to do exactly the same thing that we did last time. 9,936 bees in the beehive. Then just press equals again and we get 10,170 bees in the beehive at 2018. So there we are. That's just making sure that you know how to use the iterative sequence generator on your calculator. It's just basically by using the answer button. Okay, let's give a go at another question then. So pause the video and give this one a go. Okay, so in this question, the number of animals in a population at year t is pt. The number of animals at the start of year 1 is 400, so p1 equals 400. That's at the start of year 1. Work out the number of animals at the start of year 3. So this is the formula that we have to use. It's 1.01 times pt. So for the next one in the sequence, it's just 400 times 1.01. So I'll type in 400 and then do 1.01 times answer, and I get 404. And then for the next number in the sequence, the number of animals at the start of year 3, I just do exactly the same thing, press equals again, and I've got 408. So there's roughly 408 animals in the population at the start of year 3, if there were 400 at the start of year 1. What this is effectively representing here is a 1% growth rate, because we can see here that 1.01 is a decimal multiplier for increasing by 1%. 1 will mean you increase from where you started, and the 0.1 is the decimal equivalent for 1%. So 1% growth is what's happening in this question. Okay, let's have a go at the next question then. Pause the video, give this one a go. Okay, so the number of slugs in a garden t days is now pt, where p0 equals 100, and pt plus 1 is equal to 1.06 pt. Work out the number of slugs in the garden 3 days from now. So P1 is going to equal, I'll do it on the calculator, 100, put that in, and then 1.06 times answer, so that'll make it 106. This is effectively a 6% growth rate. Press equals again, that's 2 days later, that will give us 112 slugs in the garden, and press equals button again, and we get 119. So that'll be 119 slugs in the garden 3 days from now. So there we are, that's the answer to this question. Okay, moving on to the next question. Pause the video and give this one a go. Okay, so at time t equals 0, hours for a tank is full of water. Water leaks from the tank. At the end of every hour, there is 2% less water in the tank than at the start of the hour. The volume of water in litres in the tank at T is Vt. Write down the value of K. So because we've got 2% less water going into the 2% less water in the tank than there was originally at the start of the hour, it's decreasing by 2%. And what would the decimal multiplier be for a decrease of 2%? It would be 0.98, because you start with your 1, the whole amount of water in the tank, and then you take away 2% to decrease it by 2%. That would be taking away 1.02, so you've got 0.98 as your decimal multiplier. Okay, and moving on to the next question. Pause the video, give this one a go. Okay, the number of rabbits on a farm at the end of the month n is Pn. The number of rabbits at the end of the next month is given by the formula Pn plus 1 equals 1.2 Pn minus 50. At the end of March, there are 200 rabbits on the farm. Work out how many rabbits there'll be on the farm at the end of June. Okay, so March will equal 200. And then the next month on from there is April, then it would be May, then it would be June. Okay, so for the next one you have to apply this formula here. So it would be 1.2 times the 200 minus 50. So let's grab the calculator. Let's let the calculator do it for us. It's 200, and then it would be 1.2 times answer minus 50, which would be 190. And then you just keep on pressing equals, because now 190 is the current value of the answer. So don't type out your formula again, just press equals, and you'll be at 178. Then press equals again to get the next month, and you'll be at 164 rabbits when you round appropriately. So it'll be 164 rabbits on the farm at the end of June. And moving on to part B, consider your result in part A. Suggest what will happen to the number of rabbits on the farm after a long time. They will decrease to 0. They will decrease to 0 rabbits. Okay, there we are. That's the answer for that question. Okay, we're now going to move on to the next section of the video, which is solving equations using iteration. So the equation that I'm going to solve is this one here. So that part A is show that this equation here has a solution in between 8 and 9. So it'd be 8 point something something that will be a solution to this equation. So what I can do is I can show that when I put in 8 into my in as x, then the output, we'll call the output y, will be minus 6. And then when I put in the number 9, it goes to a y output of 2. Now what's going to happen as you go from 8 to 9, the output is going to go from minus 6 to 2. So given that between minus 6 and 2 is the number 0, which is what we want it to equal, because 0 is in between minus 6 and 2, there is going to be a solution in between 8 and 9. So you'll have to write a sentence then, because 0 is between minus 6 and 2, a solution will exist. I'm just going to write down here now, will exist between 8 and 9. So because the output's what we want, this is the output that we want to come out if we've got a solution, is in between minus 6 and 2, then there must be a solution in between 8 and 9. Let's move on to part B now. So we know that we've got a solution in between 8 and 9, so that's done. Part B is rearrange x squared minus 9x plus 2 equals 0 into this expression here. Okay, well let's start with what we want to rearrange and start moving things onto the other side. It looks like the last thing I'll do is I'll square root, which will be from this x squared. But it looks like the minus 9x has become positive 9x, and the plus 2 has become minus 2. So that's probably what we're going to do to both sides. The first thing we'll do is we'll subtract 2. And the next thing we'll do is we'll add 9x. So it'll be x squared equals 9x minus 2. And the next thing we'll do is we'll do the square rooting, because it looks like that's what the formula wants us to do. So we square root both sides now, and it's going to be the square root of 9x minus 2. And there we are. That's the answer to part B. That's how you do it. Moving on to part C now. Use the iterative formula xn plus 1 equals the square root of 9xn minus 2. So you can see here what we've done is we've used the formula that this one has rearranged into, and now this one is the iterative formula. So we're going to start with x equals 8, because 8 is near where we have a solution. So we're going to use the iterative formula, that's a rearrangement of the original equation, starting at the value that we know x has a solution in between. So type 8 into your calculator to start with. That's going to be our value for x1. Now we'll work out x2, x3, x4, x5 using this equation. So type in 9 answer minus 2 all square rooted, and that will be 8.37. The next solution, you just press equals again and you get 8.56. Oh, to 4 decimal places. Whoops, I'll have to go back one. 8.3666. The next one will be 8.5615. x4 will be press equals again and you get 8.6633. And x5, the final one, press equals again, and you get 8.7161, because the 8 will round the 0 up to a 1. So there we are, that's the answers to these numbers in the sequence. But part D is the more interesting one. What do the values x2, x3, x4, x5 mean in the context of the question? Well, let's just think about what we've done in this question. We've started with this equation up here, and we know it has a solution in between 8 and 9. And what we've done is we've taken that equation and then rearranged it into this equation here, which has then become the iterative formula. And we've also started to use this iterative formula at the number 8, where we know this equation here has a solution in between. We know it has a solution in between 8 and 9. Now what we're doing as we use this iterative process is we're actually finding a more accurate answer to this equation as we go through and generate the next numbers in the sequences using the iterative formula. So x2, x3, x4 and x5 are increasingly accurate answers, or solutions rather, to x squared minus 9x plus 2 equals 0. Like x in this equation is getting more and more accurate as we go through the sequence generated by the iterative formula. So as we keep on going from one solution to the next, this is effectively what x is in this equation here. And it's a solution to this equation here. And it gets more and more accurate the further you carry on going. So if I was to just continue pressing the equals button, at some point it would stop changing because it's got so accurate. Okay, so let's move on to the next question. This is a past paper GCSE question, so it's got roughly the same structure as the questions we have just seen before. So pause the video and give this question a go. Okay, so the first part, part A, is show that the equation x cubed plus x equals 7 has a solution between 1 and 2. But the way we do that is we put in the equation the number 1, and when x equals 1, the output is 2. And when we put in the number 2, when x equals 2, the output, we'll call it y, is equal to 10. So, because the outputs that we're looking for in the equation is in between 2 to 10, there must be a solution in between 1 and 2. And we have to actually write that out as in a sentence to answer this question fully. So because 7 is in between 2 and 10, there is a solution between 1 and 2. That will equal 7 exactly. That will equal 7 exactly. Okay, and there we are. That's the answer to part A. Let's move on to part B then. Show that the equation x cubed plus x equals 7 can be rearranged into this equation here. So we'll start where they expect us to start, at x cubed plus x equals 7. And let's have a look at where we want to go. It looks like the x gets moved onto the other side, and then we cube root. So let's take away x from both sides. That would be x cubed equals 7 minus x. That's looking more like we want to turn it into. And the next step will be to cube root. So it's going to be x equals the cube root of 7 minus x. And there we are, we've done part B. Now actually, if you can't do part B, you could still have a go at part C. So using the starting with x0 equals 2, that means we're going to start at our sequence at the number 2, use the iterative formula of this expression here. You don't need to have rearranged it to have at least had a go at part C. Still have a go at part C 3 times to find an estimate for the solution of this equation here. So what we need to do then is put 2 into the calculator and then type out the iterative formula. To get to the cube root, you're going to have to press shift and then square root to get this symbol up here, which is the cube root of 7 minus answer, and answer is representing our x number from before. So the first x number was 2, the second x number is going to be 1.71, the next x number, remember we need to do this 3 times, so we need one more after this one, is going to be 1.74 again. So it seems as if 1.74 would be the answer to this question. So there we are, we're getting an increasingly accurate answer. We've started from one side of the boundary using our iterative equation to then work out that x is probably going to be about 1.74. Okay, let's move on to the next question. So pause the video and give this one a go. So as I said, it's going to have the same structure most times. So in this question, we have to show that there's a solution in between 0 and 1. So that's pretty easy. We could even do that without a calculator. X equals 0, y will equal 0 cubed plus 4 times 0, that's 1. And then, so that's 0 rather. And then when x is equal to 1, 1 cubed is 1, plus 4 times 1 is 4, so that would be 5. So y will equal 5. And the outputs that we were actually looking for was the number 1. So because So because 1 is in between 0 and 5, there is a solution between 0 and 1. X equals 0 and x equals 1. That will equal 1 exactly. And there we are, that's the answer to part B. So part A rather. So moving on to part B then, show that the equation x cubed plus 4x equals 1 can be arranged to give x equals 1 over 4 minus x cubed over 4. Well, let's start where we want to start, where the question wants us to start. That's x cubed plus 4x equals 1, and then rearrange it into this expression here. So it looks like at some point we're going to have to divide by 4, but the x cubed moves on to the other side before that. So we'll take away x cubed onto the other side. That will leave us 4x equals 1 minus x cubed, and we'll divide by 4 and x. And generally the way I'd encourage you to write that is 1 minus x cubed over 4 like that, but it is exactly the same as writing it as if the fractions were different like that. They're exactly the same thing. So there we are, that's part B. Let's move on to part C now. So moving on to, starting with x0 equals 1, sorry, x equals x0 0, use the iterative formula xn plus 1 equals a quarter minus x cubed over 4 twice to find an estimate for the solution to x cubed plus 4x plus 1. So let's go ahead then, let's use the equation. Start with 0 and then press equals to set up 0 as your current answer value. Then type out the formula where you're using answer as your xn. And that will give you a quarter, so 0.25. So that's using it once, let's use it twice now. And in this one we're going to get 0.25 as well when you round to 2 decimal places. And if we were to carry on doing more of these iterations, keep on pressing equals, we'd get a more accurate answer. But they've only encouraged us to do it twice, so therefore we're only going to do it twice. So 0.25 here is an approximate solution to the initial equation that we rearranged into our iterative formula. Okay, let's move on to the next one. Pause the video and give this one a go. Okay, so using xn plus 1 equals minus 2 minus 4 over xn squared with x0 equals minus 2.5, find the values of x1, x2 and x3. So let's load the calculator with minus 2.5. I've used the negative number button here, negative 2.5, and then I'll type out this formula using the answer button where it says xn. So let's do that then, minus 2 minus 4 over answer squared, and the next number in the sequence here will be minus 2.64. That's x1, we've got 2 and 3 to go. Moving on to the next one, just press equals again. You don't have to retype out that formula in the calculator, you just press equals again because the new answer button is the current answer that's always on your screen at that point in time. And then press equals again, it'll be minus 2.60 as the next answer. So what's happening here in part B, explain the relationship between x1, x2 and x3 to this equation here. Well, because this equation here, if I just go back it up, we can see what it is, because x cubed plus 2x squared plus 4 equals 0 can be rearranged. We won't need to do it, we just need to explain. Can be rearranged to x equals minus 2 minus 4 over x squared, and that's the iterative equation that we've used. That's where I've got it from. x1, x2 and x3 are increasingly accurate solutions, or x's increasingly accurate solutions to x cubed plus 2x squared plus 4 equals 0, because we've used this as our iterative equation. That was the iterative equation we used, and that was the rearrangement from the initial equation. So it's an increasingly accurate solution to that initial equation. Okay, let's move on to the next one. Pause the video and give this question a go. Okay, so let's have a go at part A first then. Show that the equation x cubed plus 7x minus 5 equals 0 has a solution between 0 and 1. Okay, well we can do this without a calculator. When x equals 0, y will equal minus 5. 0 plus 0 minus 5, that will be 0. And then when x is equal to 1, y will equal 1 plus 7 minus 5, which will equal 3. So because we go from an output of minus 5 to 3, and 0 was in the middle of that, 0 is what we're looking for as the perfect output here. Because 0 is in between minus 5 to 3, there is a solution that will give 0 as the output somewhere in between 0 to 1. So because 0 is between minus 5 to 3, there is a solution to there is a solution in between x equals 0 and x equals 1 that will give an output of 0 exactly. And there we are, that's the answer to part A. Let's now move on to part B. Show that the equation x cubed plus 7x minus 5 can be rearranged into this expression here. So this is a pretty difficult one. But even if you can't get part B, there's no reason why you can't still have a go at part C and part D. Alright, we need to turn into this expression here. 5 is on the other side. That's the first thing I'll do. I'll first of all move the 5 onto the other side. So I've added 5 to both sides. Then the next thing I need to do is divide by x squared plus 7. How am I going to do that? Well, what I could do on the left-hand side is I could factorise like that. And then in the next step, divide by x squared plus 7. So it's going to be x equals 5 over x squared plus 7. And there we are. That's the rearrangement for part B. Moving on to part C, using x0 equals 1 and the iterative formula of 5 over xn squared plus 7 3 times finds an estimate to the solution of this original equation. So let's go ahead then. Let's put 1 into the calculator and then use the iterative formula of 5 over xn squared plus 7, where we use answer value as xn. So the next one will be 0.625. The next that we want to use is 3 times, so 2 more please, 0.6768 rather. And that will be x3 equals 0.67. So it looks like it's going to be about 0.67 to 0.68. Then the final thing we need to do for part D is by substituting your answer into part C into x cubed plus 7x minus 5, comment on the accuracy of your estimate to x cubed plus 7x minus 5. So what I'll do then, whilst my 0.67044830001 is still in my calculator, I'll type this into this expression here, but use the answer value instead of x. So answer cubed plus 7 answer minus 5, that will give me the most accurate answer for this. So the output is equal to, well, it's quite small, it's actually so small it's in standard index form, so it's minus 5.49 times 10 to the minus 3. If we are actually to write that as a number, it would be minus 0.00549. So you can see how close that is to the number 0. It's very close to 0. So it's a pretty accurate solution. So it's a pretty accurate solution. So there we are, that's the answer to this question. Okay, and let's move on to the final question for this video. Pause the video and have a go at this iterative formula question. Okay, so let's have a go at part A, and remember, whenever you do these kind of rearranging parts to this type of question, don't worry if you can't do it, because you can always move on to the second and third part of this question, but it's good to do all parts. So let's have a go at turning 3x squared minus x cubed plus 3 equals 0 into this expression here. Well, it looks like the 3's have moved on to both sides, so that's what I'm going to do first. In fact, no, I'm going to do the absolute reverse of that, because the 3's are positive on the right hand side here and they're positive currently on the left hand side. I'm actually just going to move the x cubed onto the right hand side. So I've added x cubed onto both sides here, and I'm actually just going to flip around the equals sign, because if something's equivalent to something else, then that something else must be equivalent to the something originally. Okay, so I've just flipped around the equals sign now, and the last thing I'll now do is divide by, well, it looks like I need to divide by x squared. That's what it says in the formula. So if I divide both sides by x squared, x cubed divided by x squared is x, 3x squared divided by x squared is just 3, and 3 divided by x squared is 3x. 3 divided by x squared, like that. And that's exactly what we're looking for in the formula here. So that's how we do that one. Move the x cubed on each other side, flip over the equals sign, and then divide by x squared. Let's move on to part B then. So in the next question here, we're going to start with using x0 equal to 3.2. So type that into the calculator first, and then we're going to use the iterative formula 3 times to work out x1, x2 and x3. So type in this formula using the answer button where you have xn. 3 plus 3 over answer squared, that would be 3.29. Moving on to the next one, just press equals again, and that would be 3.28, and press the equals button again, and we get 3.28, correct to 3 significant figures. And part C is explain what the values x1, x2 and x3 represent. They are increasingly accurate solutions to the initial equation. Now this iterative formula here came from this thing here, and this thing came from the rearrangement of this thing here. So it's the accurate solutions to 3x squared minus x cubed plus 3 equals 0. So they're increasingly accurate solutions to the initial equation after the rearrangement, so before the rearrangement into the iterative formula. So there we are, that's all we're going to go through in the Iterative Formulae GCSE revision video. That's all you need to know on iterative formulas, and feel free to come back to the video in the future and have another go at the questions if you've got them wrong this time, or maybe you just need a reminder closer to the exam. But anyway, hopefully you found this video helpful, and thanks for watching.